Okay, welcome to these videos from Math 141. The purpose of these videos is to supplement what you're learning in class, and ideally you'd watch these before class, and also they're meant to be interactive, so when you see a problem, hit the pause button and try to do the problem on your own before you watch the solution. And I want to warn you, I move really fast on these, so get ready on that pause button. You may have to watch some of these more than once. Okay, well, let's start off in section 1.4. Algebra is so important in college level math, especially when you get to your calculus class. You have to have it down. I don't assume you have it down. I just assume that you're going to be working hard this quarter. So practice these kinds of problems, okay? On this first one, so go ahead. You should be able to do something like this. Hit the pause button and see if you can simplify this expression. Okay, did you factor the top and bottom? Did you remember how to factor the difference of two cubes here? And then, oh, you can't really cancel anything, but did you remember that other trick? Whenever you have a subtraction, two subtractions that are off by a factor of -1, you could factor a -1 out of one of them, and then you could cancel the common factor, so you have a -1 left there. Remember that? Anyway, so that's your final answer. -1 times the quantity x squared plus 3x plus 9 over x plus 3. Alright, why don't you try this one? Go ahead and hit the pause button, see if you can do this one. Okay, here you're subtracting. So did you remember that you need the LCD? And if you don't use the LCD, you're going to get in trouble because that would make the denominator huge. Be really easy to make an error. So the LCD here is 2 times x plus 2 times x minus 2. Which means you're going to multiply the first one by x plus 2 over x plus 2, the second one by 2 over 2, and then when you carefully multiply this first one out on the numerator, don't you get x squared plus 2x? And here you get minus 6x on the numerator. So all you can do there, I guess, is combine the like terms on the top, and there's your final answer. Alright, let's do some more. We'll do a couple more and then I'll give you some to practice on your own. So go ahead, hit the pause button, see if you can do this one. Okay, did you notice this is a division problem, which is good. Division is a lot easier than subtraction in general, isn't it? So you'd flip over the second one, it becomes a multiplication problem, and then all you have to do is factor everything. Let's see, you factor the 2 out of here, you factor this as the difference of two squares. What can you cancel? I cancel an x minus 2, I cancel an x, so the final answer is x plus 2 over 6. Alright. Get the idea. See how we do move pretty fast here, so make sure you use that pause button. Okay, let's kick it up a notch here. See if you can simplify this one. This is called a complex fraction. Go ahead, hit the pause button, see if you can do this one. Now with a complex fraction, there are several ways to do it. One way is to just simply find the common denominator in the numerator, which would be, wouldn't it be x, so you'd have to multiply the numerator on top, you have to multiply this 1 on top and bottom by x, and then find a common denominator on the denominator. The common denominator here would be x squared, so you'd multiply top and bottom of this number 1 by x squared. So what does that turn into? Well, that becomes 1 minus x over x on the top, and this becomes x squared minus 1 over x squared on the bottom. So when you flip over the bottom one now, you get to this stage, and the next step is to factor, but you know that we have that issue again, remember? When you factor x squared minus 1, it's going to be x plus 1 times x minus 1. X minus 1 and 1 minus x are off by a factor of -1, so you're going to take a factor of -1 out of one of them. I'm taking a -1 out of the 1 minus x, leave everything else the same. That allows you to cancel the x minus 1 and also one of the x's, right? So that's why I get -x over x plus 1. Okay, so again, when you work these problems also, make sure you pay close attention to writing the whole problem down and using good algebra skills, because teachers will mark off even if you get the right answer. You have to show your work, and you have to show your work clearly. So that's one thing you should work on this quarter. Alright, let's look at this one here. Go ahead, hit the pause button, see if you can do this one. Now with this one, did you move the x to the -1 down to the denominator? You really can't do that because of this addition sign here. The only thing, a better way to approach it would be to just write this as 1 over x and write this as 1 over y and treat it as a complex fraction, you see, but you can't move the x down here because it's being added. not multiplied. So anyway, once you do that, you have to get the LCD on the top, like before, multiply by y over y here, multiply by x over x here, and you end up with y plus x over xy over y over x squared. Now you can flip over the bottom one and write this as x squared over y, and then you could cancel the common factors. Are there any common factors? It looks like just an x is all, right? So that's your answer, x times the quantity x plus y over y squared. Alright, let's do one more, then I'll give you some to practice. How about that? Alright, see if you can do this one. Okay, on this one you actually can bring the exponents down, because see, there's a multiplication here. Everything's being multiplied and divided. So you can use your rules of exponents. X to the negative 2 comes down, this becomes an x to the 5th in the bottom. Y to the negative 1 comes up, becomes a y in the bottom. That's why you get 1 over x squared times y squared. I should say 1 over x to the 5th times y squared. Anyway, okay, well here we go. Let me give you 3 to try. This is going to take a while. Go ahead, hit the pause button, and see if you can work these 3 problems out. It should take a while. And then we'll go over them when you're done. Okay, and the first one is a subtraction problem, right? So you're going to have the LCD. Isn't the LCD going to be x plus y times x minus y? So what you're going to do here is you're going to multiply the first one on top and bottom by x minus y, the second one on top and bottom by x plus y. Now be careful. What do you get when you multiply x minus y times x minus y? On the numerator there you get x squared minus 2xy plus y squared. And what do you get when you multiply x plus y times x plus y? You get x squared plus 2xy plus y squared. And see this minus sign that's in between? This minus sign is governing the whole numerator, so you have to distribute that. The denominator, of course, is x plus y times x minus y. Now when you distribute that minus sign, do you see that the x squares are going to cancel? And you also see that the y squares are going to cancel? So what do you have left? You have a negative 2xy here. You're going to get a negative 2xy here. That's your final answer, negative 4xy over x squared minus y squared. Alright, let's look at this one. This one is a very important problem in your calculus class. This is the kind of algebra you have to be able to do. It's a complex fraction. We're going to have to get the LCD. The LCD here is just going to be x times x plus h on the top, right? So you're going to multiply this expression by x over x, this expression by x plus h over x plus h. It's just over h. Now when you multiply it out, remember this minus sign here is governing the numerator, so it's going to actually change the sign of each of these, isn't it? You're going to get x minus h on the top. The denominator is going to be x plus h, and of course that's all over h. So what do you get then? On the numerator then, you get x minus h over x times x plus h times 1 over h. The x's cancel. You see the x's cancel? And now the h's cancel too. This h cancels with this h. Final answer is just negative 1 over x times x plus h. That's the level you have to be at. Let's look at this. Let's look at this last one here. Now this one looks easy. It looks like the answer is just a plus b. But that's wrong. It's not. And the reason, of course, is because we don't have a rule of exponents that applies when you have the sum of things to a power. It's only when you have the product, right? So what do? Well, you do it the old-fashioned way. You'd write this as 1 over a plus 1 over b to the negative 1 power. So it becomes 1 over a plus 1 over b. So it's sneaky, but you have to be able to recognize that. So you get the common denominator on the denominator then. Multiply this by b over b, this by a over a. So you get 1 over, this becomes b plus a over ab. We're almost done. Once you do this, then you flip over the bottom one. So it's 1 over 1 times ab over a plus b. Your final answer is ab over a plus b. Alrighty, well, we'll see you next time. Bye-bye.